Page 116, you said?
Yeah, that's
Okay.
not machinist. It's a precise definition of the question.
Yes, page 116, number?
Sorry, 117, number 11.
Number 11. Okay, number 11. Okay, so he's required to manufacture a circular metal disc with an area. Okay, what radius produces such disc? So it's a circular metal disc with an area. So we know, so part A. So what is the area of a circle? It's circle because it says circular metal disc. So good. So then all I have to do is set this equal. Pi r squared equal to 1,000. How do I solve this for r? Very good. So this is r squared equals 1,000 divided by pi. And then I will have to, very good. And I will not write plus or minus. I normally have to write plus or minus when I take the square root. But since it's a radius, I will have just positive. So this is the square root of 1,000 divided by pi centimeters. We always have to write the measurement unit. Okay. If the machinist is allowed to an error of tolerance, okay, plus or minus 5. So plus or minus 5 centimeters squared. In the area of the disk, how close to the ideal radius in part A must the machinist control the radius? So obviously this is the function, right? And this is the x. Okay, so we are told that there is an error for area, which is 1,000, right? Or pi r squared. So pi r squared, right, minus, so when we write the error, so this is what we have, so 5 centimeters, right? So the error in the area cannot be, so it's positive or negative 5. So negative 5 less than 5. So whatever we decide to put in here for the area, right? So the area minus 1,000, because that's our limit. We want the area to be 1,000. Okay? So when r approaches the optimal, the area approaches the optimal. So the optimal is 1,000. So the area minus 1,000 in absolute value has to be less than 5. How do we translate this? So a minus 1,000 must be between negative 5 and 5. So let's summarize this one more time. We're told that the disk has to have an area of 1,000. So as r approaches, as the radius approaches the correct amount, or the correct number, the area must approach 1,000. So area is the function in our epsilon delta definition. 1,000 is our L, right? And R approaches, we'll see in a moment. Okay, so then from here I will replace A by pi r squared minus 1,000 is less than 5. And I will add 1,000. So I have 995 less than pi r squared and less than 1,005. I will divide both sides by pi. This is not allowed. What I'm going to do next is not allowed in an inequality unless all three numbers are positive. Are they all three positive? Then I will take the square root. Again, I'm not allowed to do this in an inequality unless I'm absolutely certain that all three are positive. Any questions so far? Okay, So I'm gonna grab my calculator or use the software. So let's say what we get with the square root of 995 divided by pi. And what I get with the square root of 1005 divided by pi. So I got that this is 17 point, I'm going to use as many digits as I can, not millions, but let's say the first one is 17.79658 less than R less than 17.88578.865. Okay. So I'm going back to the problem and I read the question one more time. If the machinist is allowed an error tolerance of plus or minus 5 centimeters squared, which is on the area for sure, in the area of the disk, how close to the ideal radius in part A must he control the radius? So in other words, here we were given epsilon. Epsilon was 5. 5 tolerance plus or minus from 1,000. So if you remember from our graph for the epsilon delta definition, this is the 1,000, and this is plus or minus 5. So obviously this is 995. Oh, the other way around, of course. 1005. So whatever function, of course, it's pi r squared, it's quadratic, it doesn't matter. But what I'm saying is, so this is one distance, and this is the other. Now, when I calculate r from here, I did not calculate that. The square root of 1,000 divided by pi, I get 17. So r equals 17.84124116. I don't know how many decimal digits they want, so that's why we'll figure out in a moment. Okay, so finally, I will have to determine the distance between this and put it here. Then the distance between this and put it here, like we did with epsilon delta definition. Finally, which one of these two, of course, don't look at my graph in the sense that it's not an exact graph. I was just referencing back to what we did. So which one will I pick? Which one will I say to him, hey, make sure that you're within this if you want the error to be within 5 for the area, 5 centimeters squared. So I have to determine the difference between 17.8 blah, 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 minus this, and then this minus that. And which one will I choose? One more time. The
Smaller.
Perfect. So I'm going to do that. So from this, I subtract 17.79658. So this side here is 0.0446616. That's more than enough. He's not going to measure that for sure. And the other one is 17.88578865 minus 17.841244116. 8412416, yes. And this one is 0.044544749. So we will tell him to choose our delta or the tolerance for the radius. That's what it means. Of plus or minus, which one? So I have 0044 is the same. So I have to choose the 5, right? So I'll say, I don't know how many digits they use. How many digits do we want to use to tell him plus or minus? It doesn't say. It doesn't say, but how much can they measure? in centimeters? Point what? Maybe 2 microns or not even that. Okay, so let's say 2, 4, I'm going to use 6 digits. Plus or minus 0.044547. So, in order for the area to be within plus or minus 5 squared centimeters, the radius of this disk must be for sure, not to create more area, more error in the area. What? Of course, has to be centimeters. So a tolerance from that 17 point blah, 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 not more than 0.0 plus or minus left and right, left and right of that number, 0.044547. And there is a part C here in terms of epsilon delta definition. What is x? We know what is x. The radius. What is f of x?
Pi r squared.
The area. Very good. What is a?
1,000 over pi, square root of 1,000 over pi.
Exactly. 17. Perfect. What is L?
1,000.
Okay. What value of epsilon is given?
5.
Very good. What is the corresponding value of delta?
Really small.
0.0444547. Very nice. Good problem. Now we see an application of the epsilon delta definition because we thought, oops, why do we need this? Awesome. Thank you for asking that. Good. Next question, next problem. Anything else you had? Robbie, you had something. I'm sorry. You probably raised your hand at the same time. I apologize.
When we have to make the graph, one of the problems in the packet said the function is odd.
Very good. So let's talk about that. So symmetry. Again, thank you so much for asking for 2 reasons. Number 1, because there is a problem that I chose for packet for you to turn in. Number 2, it will save me time in chapter 3 because I need to remind you of that anyway. So let's do that. Very good. A function can be, I'm going to go to the next page. And you have, this is your homework to tell me why the graph disappeared on the previous handout. I mean, it still puzzles me. Okay, so functions are symmetric. It's nice that they are. So symmetry or symmetric functions. Not all functions are symmetric. But the symmetry is of 2 types. What it's called odd and what it's called even. Odd symmetry or odd function has nothing to do with odd numbers like 1, 3, 5, 7. Even symmetry has nothing to do with numbers like 2, 4, 10. Okay? So let me graph a function. If you remember what the function this is, please let me know. Thank you very much. Very good. So here's what I am going to do now with this graph. I'm going to draw a line segment that connects. So this is indeed x cubed. So I'm going to draw a line segment that passes through the origin and connects 2 points on the graph, one in the first quadrant and one in the third quadrant. So I'm going to start here. This is the origin, and I'm going to continue till it hits the graph on the other side. Okay, I'm going to give you x here. Disregard the fact that this is x cubed. It doesn't matter. I just want to work on a function f of x, but it's x cubed indeed. I would like you to give me this, the y coordinate of this point. What is it? Thank you. Now, by construction, and because it's clear what I'm trying to do, what do you think this value is? Of course. Now, do not look at this. I don't want you to look at this. I would like you to tell me what is this value for sure. Awesome. That's all I want you to say. And now my final question to you is this. Can you please find a relationship between this length and this length? If I say 10 here, what do I have to say here? It's obvious, right? Okay, if I say here 5, what do I have to say here? Perfect. So now I'm asking you this. What do you think the relationship between f of negative x and f of x is? So when this is 5, this is negative 5. Or when this is negative 5, this is 5. So what will be the relationship between these two numbers?
Their sum equals 0.
Yes, they're opposite. It's the same thing that you just said. Their sum must be 0, or they're opposites. Yes. F of negative x must be the opposite of f of x. Do we agree? This happens only if the function is odd. Odd function. And now we will have to conclude. Odd function is symmetric with respect to, I'm lazy, WRT, with respect to what?
Y equals x.
So careful, what I graph here, I graph here. Or what I graph here, I graph here. With respect to? Very good, the origin. So knowing that the function is odd, and we'll come back to the question, whatever I graph in the first quadrant, I have to have a copy in the third, or whatever I have in the second, I have to have a copy in the fourth. So an odd function requires or tells us that the graph is symmetric with respect to the origin. Let's look at even now. I'm going to graph another function. Of course, I cannot use the same one, obviously, for obvious reasons. Can anyone tell us what this function is?
X squared.
Awesome. I'm going to draw a horizontal line anywhere you want. I'm creating 2 points, and I would like you to, when I give this as x, I would like you to tell me what is this value right here. And it doesn't matter. It's the same for any function that has this property. So what will this be?
Negative x.
So this one is f of x. Good. And you're right, you're ahead of me. This is negative x. Perfect. And then don't look at the other side. And please tell me what this will be for this point.
1/2 x.
F negative x.
Very good. So this will be f of negative x. Now I want you to come up with a relationship between f of negative x and f of x for any even function. Say it again. Yes, there will be symmetric. The function is symmetric with respect to the y-axis, but I need the relationship between f of negative x and f of x first.
Equivalent. F of negative x equals f
Of
x.
course, they are the same number. Absolutely. They're the same point, they're the same number. F of x is here, f of negative x is here as well. Very good. So even functions, or even function is symmetric. Again, WRT with respect to the, what I graph in the first quadrant, I have to graph in the second quadrant. With respect to,
Y-axis.
very good. Does this solve the problem with the question or not? Will you be able to finalize that? Yes, Tom, go ahead.
What about the x-axis?
Very good. Perfect question. Perfect question. Yes. Thank you. Here it is. So this is symmetric with respect to the x-axis. However, it is not a function. So yes, a relation can be symmetric with respect to the x-axis, symmetric with respect to the origin, and symmetric with respect to the y-axis. Here is an example. You will see this later. Here's a very good example of an equation that is symmetric with respect to everything, all three. Symmetric with respect to the origin, symmetric with respect to the y-axis, symmetric with respect to the x-axis. But it's not a function. Good. Any questions other than what we had? Anything else? Anything else? Robbie, is that the only one, or you had something else?
For number 34 on the packet, can you find a question that's similar to that?
Yes. Number 34. You mean problem 30? So in 34, first of all, we have not discussed 2.7 yet.
Or 33, I'm sorry.
Oh, that's okay.
Yeah.
So it's 26, 34, 38?
34.
Oh, this one, 34. Oh, I see. So 34 on page 141. Let's take a look. 34. Yes, we did that in class. Yeah. But I can choose another. Yeah, we did that in class. I forgot that I put it on there, but maybe not. Maybe we didn't do it. So, but I think we did. Let me choose another. Or we can, no, I don't think we did one. You know what, let's do that one. I just can't seem to, we can make one up, or we can do that. I'm looking at the end of the chapter to see if there is another example like that, but I just can't find one. I'm looking on page 167, and there is nothing similar to that. Yes, let's do it. Let's do that in class together. Okay, so 34. We have limit as x approaches infinity from e to 3x minus e to negative 3x over e to 3x plus e to negative 3x. Okay. Two things I want to discuss here before we even attempt the problem or plug it in to see what case it is, okay? So if you remember, this is one of the graphs that I said, please commit this to memory. So this is the graph of e to the x. E to the x or e to 3x is very similar, or e to 2x, they're all going to be the same shape, okay? So obviously when x approaches infinity, what is the limit of just this? Infinity. What is the limit of just this? Right. So this will go to infinity and this will go to infinity. Very clear, right? As x approaches infinity, the function goes to infinity. Agreed? But now let's analyze this other piece. There's one more piece in there. And if you remember, e to negative 3x is the same with, it's very important to remember, a negative exponent means? Perfect. Now this is a different story than this. So now this piece goes to infinity as x approaches infinity, right? Just this piece, not the whole thing. But where will this go when this approaches infinity? Exactly, we discussed that. Awesome. So this approaches infinity, 0, 0. So the numerator approaches,
Infinity.
very good. The denominator approaches, correct. So here we have on our hands another indeterminate case, which is infinity over infinity. Agreed so far? Everyone? Can you follow? Yes? Okay. So in this situation, I have to decide to factor out something. I have two options. I can factor out e to 3x from both, because that's the powerful element, which I prefer. Or I could factor out e to negative 3x, but I don't really have all the tools just yet to do that. I can factor, but I still cannot finalize it. Later on, I'll explain the other option. So in this case, let's take out the most powerful one. So this is limit as x approaches infinity. I will take out e to 3x, and I will take out e to 3x. Now I have to be careful what I have in parentheses. So e to 3x times what is e to 3x? Obviously, that's the easy part. What is it? 1 in both cases. The top has minus, the bottom has plus. So now, e to 3x times what is e to negative 3x? To negative 6x, very good. E to negative 6x, because I copy the base, e to 3x multiplied by e to negative 6x, I copy the base and add the exponents. That's how I get back the negative 3x. Very good. Do we agree? Yes? Good. What do you think I'm going to do next? Get rid of e to the x, 3x, done. Now I know where this is going, and I know where this is going. Where are they going?
0.
Yes, because it's e to 1 over e to 6x. So if this goes to 0 and this goes to 0, where does the whole thing go to?
4.
Exactly. Thank you very much. Which means something about the function. When the limit of a function is a number, what do we know about this function? Y equals 1 is a horizontal asymptote at infinity. It may be at the other end because we really haven't looked at it. I don't know. We have to check. But for now, I have to write infinity. Is this better? Okay, perfect. Anything else? Do we have other questions? Anything else? Anything else? Okay, in order to consider 2.8 finished, do we need another f prime? Yes? Very good. So let's look at another f prime. Yeah, I think we did a square root. I think we did a rational. You want to do another rational?
Yeah.
Perfect. Let's do 28 on page 163. So we have f of x equals x squared minus 1 divided by 2x minus 3. Then I would like to show you how to graph a derivative of a function. And then we can look at the examples in 2.7. I'm looking to see if I chose 28. No, I didn't choose 28. Did I? Yeah, I did choose 28 on 163. Can I change it? I did choose on the packet. So I'm looking at, is that okay with you if I change it? Can we make one up? Let's make one up. Give me a rational function that you would like to work with. It can be similar to that one. I don't have a problem with it.
X squared.
Okay, let's say 2x squared. Let's say plus 3 divided by 4x minus 2. Good. So we're asked to find the derivative of this function. Find f prime. Oops, I didn't mean that. Not the inverse, but find f prime. And using the definition, we do not know anything else just yet. So please dictate. How do I determine f prime for this function? What do I have to write? This part we have to commit to memory. We need to remember what this is.
The limit of the difference quotient.
Yes, as h approaches 0, from f of x plus h minus f of x divided by h. Only now I will put it in. So let's put it in. So limit as h approaches 0. Please dictate. This is not an easy or trivial problem because of this x squared. Everything else would have been much easier, but that x squared messes us up. But not for long, because we will figure it out. So 2 parentheses,
X plus H
very good,
squared
plus 3,
plus 3 minus
4x plus 4h minus 2. Is this clear? Are you with me, everyone? Okay, then minus 2x squared plus 3 over 4x minus 2, everything over h. So then limit as h approaches 0. Oh, I cannot do that just yet. I want to square that first. So I can delete that. So 2, and please tell me what is x plus h, everything squared. But remember, we have an agreement.
X squared
Make me proud.
plus 2xh, or, yeah, plus h squared.
Awesome. Plus 3, everything divided by 4x plus 4h minus 2. And then minus 2x squared plus 3 divided by 4x minus 2, everything over h. Everyone with me so far? Okay. Perfect. I still have to do one more thing. I would like to distribute 2 and then find the least common denominator. So limit. So 2x squared plus 4xh plus 2h squared plus 3 over 4x plus 4h minus 2 minus 2x squared plus 3 over 4x minus 2 over h. Are you with me? Do I need to wait? Okay. Least common denominator.
Gotta cross multiply.
So I like to say that for proportions, but I know what you mean, and I know they say that in high school. So yes, so this will get a 4x minus 2, and this will get a 4x plus 4h minus 2. So indeed, the least common denominator is the product of the two. And now carefully, let's distribute. So let's start by distributing from the binomial, always. So 4x to these 4 terms, and then negative 2 to these 4 terms. Then negative 2x squared to these 3 terms, and then negative 3 to these 3 terms. Now let's stop for a moment and remember two things that have to happen here. What are those two things that have to happen whenever we determine the difference quotient and then the limit? But the difference quotient, two things must happen.
Terms without H have to
Or
go away.
bonus other terms maybe, but terms without H must go away. And then eventually, what else must go away?
The H in the denominator.
This particular one, not this, but this one. Correct. Very good. Just remember that. It's good. So 4x times 2x squared. As you know, I will always, run out of room. So I'm going to write on the top. Who knows? So 8x cubed plus 16x squared h plus 8x times h squared plus 12x minus 4x squared minus 8xh minus 4h squared and minus 6. And of course, as I expected, I ran out of room. So now I'm going to continue here. So this piece continues here. Not with two minuses, but it says there is something that follows. Negative, I already have the negative. Negative 8x cubed, negative 8x squared h, and plus 4x squared. And then minus 12x, minus 12h, and plus 6. So one more time, negative 8x cubed, negative 8x squared h, plus 4x squared, minus 12x, minus 12h, but plus 6. So we are hunting for everything that does not have h in it. Here's one with this one. Here's another with this one. Here's another with this one. Here's another with this one. Now, (16x squared h). Okay, this will be combined here. This piece will be combined with this because it's 16x squared h and negative 8x squared h. Let's see if there is anything else we can combine. I don't see anything else. So this is by itself, 8x h squared. There is no other 8x h squared. The negative 8xh, nothing. Negative 4h squared, nothing. And negative 12h, nothing. However, so after I combine these two, I notice that all the remaining terms have what in common? They have to. Okay, so I'm here with limit. H approaches 0. I'm just going to flip h, so it's h. 4x minus 2, 4x plus 4h minus 2. Now I'm going to write the numerator. This with this. It's 8x squared h. These two are gone. Then plus 8x h squared minus 8xh minus 4h squared minus 12h. And yes, all of them have h in common. It will be pulled out. And when you're ready, please tell me what is left in parentheses. And how many terms do I have to have in parentheses?
1, 2, 3, 4, 5.
Perfect, indeed. One from each. So when I pull h out from the first one, what is left?
8x squared,
From the second one,
8xh,
from the next one,
8x
minus 8x, from the next one,
minus 4h,
and from the last one,
8.
that's it. The next step is?
Take h out of the
Good. So now the problem is gone. All we have to do now is figure out which terms will go away. I no longer need the limit operator. I'm ready to write the final answer. So, where does this go?
0.
Yes, because h approaches 0. Awesome. Where does this go? Good, because h approaches 0. And where does this go? Good. So please tell me what is left at the top.
AF squared minus AF minus 12
And the denominator.
minus 2 F squared.
That's it. This is a derivative function of the function we created. It gives the slope of the tangent line to the graph of f of x at any point where the function f of x is what? I'm looking for a word. It gives the slope of the tangent line to the graph of the original function everywhere where the original function is differentiable, meaning continuous and not having a cusp, corner, or vertical tangent. Awesome. Good. So now I would like to, any questions on this problem? I cannot put a problem like this on a test on final exam because it took us, what, 15 minutes, 10 minutes? No, it's not reasonable. This is not the only thing I want to test. But this is for homework. Okay, so I would like us to choose a function either from 37 through 40, any graph you want, or better, trace or copy the graph of the given function, blah, 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 from 4 through 11. So this is asking us to copy the graph of this function and come up with an estimate of the graph, an approximate graph for the derivative. I want you to see this. I need you to see this. We can also pick from here, from 3, from A through D. We can choose one and then verify with the derivative.
Can we try maybe number 7?
This one?
Yeah.
Very good. So let's look at number 7. I'm going to graph it here. Please make sure you have room underneath the graph because I'm going to trace from the top to the bottom. So these two coordinate systems, they have to be one under the other. 100%. One more time, any questions on the previous problem? Anyone? Okay. So this will be the graph of f, and this will be the graph of f prime. So we picked a semicircle. Is it better to say semicircle or semicircle? Okay. Always correct me if I'm wrong, please. You help me. Okay. So I start with several points and try to, of course, this is a rough estimate. I don't have a grid here. I cannot really measure anything. So this is going to be a rough estimate. But you need to see how this is determined. Okay, so let's say I pick this point. I'm going to say that this tangent, I'm going to draw a tangent. And of course, I'm going to say that this is like maybe 2 units and this is maybe 1.5. I'm coming up with numbers. Don't ask me how. I don't have a measure. It appears to me that this is a little bit higher than this, and I'm going to say 2 over 1.5. The slope of this is rise over 1. Then I'm going to present a point here and draw the tangent, and I'm going to say, obviously, this appears to be 1 and this appears to be 3, to me. Okay. I'm going to draw the tangent here, and then I know that this is, so the slope of this line is 1 over 3. Obviously, the slope of this line, there is no discussion here. Okay, what happens here? Right, so this is a vertical tangent, which means the derivative will be undefined at that point. Obviously here the derivative will be 0. Okay, so let's continue now. I'm going to draw a tangent, a point here, and I'm going to draw the tangent. And again, I'm going to say this is roughly 1/3, but this time this slope is, yes, negative rise over run. Okay, I'm just coming up with numbers, as you see, right? Can't read anything. So I'm going to say this is the tangent, and I'm going to draw a triangle right there. I'm going to say that this is 2 and 1. I'm not at the same spot, so it's not 1.5. And of course, here is a vertical tangent. So right here, the derivative is undefined. So the slope here is -2. All I have to do now is take these numbers and plot them here for each corresponding value. So this was here. This was here. This, of course, is here. Now, 2 divided by 1.5 for this point, for this x value, and then for this x value, and then for this x value, I have to use the same x, and for this x value, I will come up with the slope. Okay, so 2 divided by 1.5 is 1 point blah. I'm not going to be able to graph it anyway, so I'm going to say this. Here is 1 divided by 3. So this was 1. Let me go a little bit higher because the graph will be just too tiny. So I'm going to, go a little bit higher with a unit. So I'm going to say this because I have 1. Okay, so I'm going to say somewhere here. Then this one obviously is 1 divided by 3, so this is 0.3. Question is, where do you think on this graph the tangent is the highest? Well, this is undefined. This is definitely high. This is smaller and smaller and smaller and smaller and gets to 0, right? So
there's a vertical aspect.
So I would say, so it's coming from positive values, from big positive values towards 0, right? So this something like this. Since this is symmetric on the other side, the derivative obviously will be symmetric. But negative, of course. All these numbers are negative. So from small negative to bigger negative to bigger negative to bigger negative, but it's undefined at that point. Of course, this is not part of the graph. I was just, maybe I should, I don't want to confuse you. I just wanted to show that the function, the derivative is not defined at those points. Okay, so this is how we determine the graph of a derivative function for a given function. Okay, the last thing that I wanted to show you is from section, oh yeah, one thing that to finalize 2.8 completely, I want to show you the notations for the derivative. We're going to be using f prime. This is on page 21 at the last page of the checklist. So we encountered these 3 indeterminate cases. We did not encounter any powers, and we did not encounter the product yet. And number 42 is just what we showed in class. A function is not continuous or has a cusp or a corner or an infinite tangent. So you can put those graphs in here. Please do not turn this in. I want you to keep it to study from. Just make a copy of what you're turning in so you can also keep that with you so I can post the solutions on Thursday. So we're going to be using this notation, and this notation. The other ones are possible, but you may see them in other books. So this is the so-called Leibniz notation. So this we are going to use the entire semester these three notations. Why three different notations? Because they are used in different ways. Okay, so that's very important. Okay, so now I would like to show you. Don't think I have anything else that I forgot. So yeah. So the last one. Any questions, please?
That's on Thursday.
A week from today.
Okay, so
So this Thursday, we're going to turn in the checklist, and after I finish this, which will take a few minutes, then I'm going to give you a packet, and we'll start working on the packet. Okay, it's a previous test that I gave. It has, I think, 11 or 12 questions. Okay, so now finally, let's go back to 2.7. 2.7 is a special case of 2.8. So derivatives and rates of change. Well, this deals with f prime of a. What is the difference between f prime of a and f prime of x? What do you think? Please.
F prime of A is just 1 point versus.
One value, a number. What is this? Very good, awesome. Indeed. F prime of x is the function that gives the tangent, the slope of the tangent line to the graph of a function where it's differentiable. But f prime of a is just one slope at one point, just one number. Is that clear? Okay, perfect. Now, how many definitions we have for f prime of x? Just one, right? So let's write it one more time. Can anyone refresh our memory? When I was growing up, I don't have siblings, but I have two cousins, and my grandma had two daughters, my mother and my aunt. So my grandmother would talk constantly, and we were kids growing up, and they said, "Oh, can you make us stop? Can you make us stop?" So we're joking among each other. And now I sound like her. I repeat and repeat, I repeat. Okay, so forgive me. So, f prime of x. It's the only way. He's here finally. How was the review?
awful.
What do you mean awful? I